feed of Australian plants. So Professor Han talked about the three subjects before, and for me, I'm going to speak about concurrent engineering, design change management, and SCM, supply chain management. Like before beginning, some of the motivation of doing a feed and stuff like that. It's like there is a many complex interdependent parts, independent parts as well. So you need to make sure that everything works together in a safe way. And also a good management is important from the start. Like for example, like a bad management, like it was a Deepwater Horizon in April 2010. It was an oil drilling rig in South Korea by Hyundai, operated by Transocean, but they had an issue when they drilled in the Gulf of Mexico because of bad management of British Petroleum. There was a movie recently with Mark Wahlberg about the situation. You can look it up if you want, explaining why it's failed. So, like there is the design process, like as Professor Han talked before, the engineering team, the clients who want to make the feed. Yeah. There's another graphic about the same thing with a little bit more detail about what the engineering need to send to the vendor or the client. About the concurrent engineering, before the engineering process, about the EPC was only horizontal. Like once the engineering team made their design, they sent it to procurement for the supply chain, and after that it went directly to construction. But now with the concurrent engineering, it's more vertically. Like the engineering team don't need to finish their design in the midway; they can send directly to procurement, so they'll lose less time than before. But that's the main advantage of that, like less time to do the project. But one of the disadvantages is like there is a lot of stress and pressure about the different team, because if engineering team fail a design or need to rework the design, the procurement need to go back again to buy another part or something like that. Sorry, yeah, like it was more detail about the past sequential execution. You can see the engineering who sends the bill of material to the procurement to buy the materials and send the drawings to the construction after the procurement. But now it's more or less something like that. The engineering team sent a first draft of bill of materials that procurement need to buy. Then the drawing to construction, and after that, for the second part, for the last part, they send another bill of material. Like as I've said before, like there is some other challenges because of that. Like the engineering team need to put the design to have the input design really early, and really need to avoid changes and reworks, because if there is some changes, they need to do again all the process with the procurement and construction, and they're going to lose time again. So yeah, like there is a little bit of detail as well. So about the process of the engineering, we need to have the design earlier. But as I said, you need to get right, because like if there is an issue of the safety valve duty, they need to rework again. They need to recalculate everything and do the full route again at the beginning. So, so there is some ways to avoid changes. like they know from their experience sometimes some technical issues that can maybe happen. They can also have a third-party interface that can look up after them to see if there is some avoidable change or something like that. The important other parts too is to control your suppliers during your full project. As you know, to an ocean plant, there is a lot of parts involved. If there is a change of suppliers, that means there can be a change of way of manufacturing the parts. And if there is a change of materials, like for example, for steel materials, there is some recalculation about the structure that we need to redo again because it can be a little bit different. So now it's a little part of the project organization. As you can see, there is a lot of people involved. Like you can see the engineer part of only this way for the design, and there is all other people who are involved to the project manager who need to manage everyone. So here there is a process design after the feed, after the engineering design. Like we have something called a P&ID, where the P&ID is served to. It's used by the procurement team to know what kind of parts they need to buy. They use for that some schematics and some tools, some software. Like there is a process overflow, as I said, like there is a PID pipeline and instrument diagram. That's the main part of the procurement. There is a main material used in a plant. I'm not going to read everything. It's explained all the process. You can read it after the lecture. So here you can see after the feed, it goes to the piping and instrumentation diagram where it shows what kind of instrument they need to buy. So here a little drawing of the piping and instrumentation diagram. Like there is a lot of little symbols, but they are all standard. Like there's standard for valves, some for pump and stuff like that. It's easier to the procurement team to know what kind of things they need to get. Like here, a little video on how to read a PID.
아빠도 그런데 엄마까지 그런 판정을 받으니까 엄마가 죽을 수도 있겠구나. 많이 못 사.
In many of our RealPARS videos, we discuss control system and instrumentation, which is something that engineers encounter on a daily basis.
이거 어떻게
화면 공유를 PPT로 하면 화면 전체
이거 제가
합핑했죠. 근데 이게 잘 안 되는구나.
In many of our RealPARS videos, we discuss control system and instrumentation devices in great detail, so you can understand exactly how they work. In this video, we will learn how to read a P&ID, which is something that engineers encounter on a daily basis. At RealPARS, we love helping the like button. So you'll never miss another one. Diagrams, to give them their full name, are schematic representations of pipelines, equipment, instrumentation, and control systems found in process environments such as oil refineries, chemical plants, paper mills, and cement plants, etc. The symbols contained in P&IDs represent the equipment in the process, such as actuators, sensors, and controllers. Process equipment such as valves, instruments, and pipelines are identified by codes and symbols. As well as devices and pipelines, a P&ID will commonly contain information on vents, drains, and sampling lines, as well as flow directions, control I/O, and interconnection references. The instrumentation codes listed in P&IDs follow a standard format. After some practice in reading P&IDs, you'll know these codes by heart. But in the meantime,
I'm not going to put all the video. You can look it up after if you want. But that's basically how a P&ID works for the procurement team. After that, I'm going to talk more about the purchase team, like the supply chain management. You can see there is a process design with the PID who sends the piping and instrumentation to the purchase supply team. You have also the PFD, the process to send also more heavy equipment to also to the same team. Here are more detailed diagram about that with the vendor and every other team members and messed up. So, yeah. So that was all for me. I don't know if you have questions or. Oh.